This video will provide an overview of text data in R. By the end of this video, you should understand what text data are and how it is stored in R, what escape sequences are, and how they are represented in text data, and how you convert numbers stored as text into numeric data. The R code that I show in this video is available on Elms, and you may want to take a minute to download it and open it if you'd like to follow along on your own. Before discussing dealing with text data, it's important to define exactly what text data are. Remember that R stores numbers and text differently. Text data are surrounded by quotes and contain strings of character of arbitrary length. Technically, a string can only be 65,000 characters, which is several times longer than the analysis project memos that I expect you to write for this class. The R data type for text is character, or sometimes represented by CHR. Text data are often called strings because they're stored as strings of characters. You're going to surround these strings with either single or double quotes. It doesn't matter which you use as long as they match. The first two examples that I have here, where hello world is enclosed in first double quotes and then single quotes, are both valid strings, but it's invalid to start with one type of quote and end with a different type of quote. What are the advantages to being able to use different types of quotes? You might use double quotes if your string contains single quotes. So in this first example, there's an apostrophe in my text, and so I use double quotes to start and end the string. R knows the apostrophe is part of my string. In the second example, I have some double quotes inside of my text, and so I use the single quotes at the start and the end to let R know that there might be double quotes inside. As an alternative to mixing single and double quotes to get the string that you want, you can also escape quotation marks with a backslash. What that means is, when you'd like to include a quotation mark in your text, you use a backslash, then the particular quotation mark that you'd like to use. R knows that whenever you type a backslash, that there's some sort of special character that will come after it that forms an escape sequence. In this case, you could include double quotes in a string using backslash double quote, or you could include single quotes in a string using backslash single quote. There are actually many escape sequences in R that denote special characters. So the single and double quote that we showed before, backslash n denotes a new line, backslash t denotes a tab, two backslashes denote a literal backslash, if you'd like to actually include a backslash in your text. Backslash x and then two numbers represents a hexadecimal character code, and backslash u followed by four numbers represents a Unicode character. This can become very complicated if you'd like to include actual backslashes in your text. The print function in R is going to print a string coded exactly as you would need to type it to create it. So in this first example, I use a single quote to denote the start and the end of my string and have some double quotes inside. R will always represent your strings surrounded by double quotes. Here it uses the backslash character to denote that the quotes inside the text don't end the string, but should be included inside. Sometimes this isn't what you want. If you'd actually like to print the text out as it should be interpreted, so ignoring these special formatting codes, you can use the R function writeLines. That will print out text as it is meant to be literally interpreted, so it will ignore those R formatting codes. Let's look at some examples of loading text data. All of the text data processing functions are part of the tidyverse. We'll load that first. Just as some examples, you can store the text hello in double quotation marks and print it out. That returns the string hello. It's the exact same if you use single quotation marks, as I have in my next example. R will still print it out in double quotation marks. These are just to denote the start and the end of the text. Remember, if you have special characters in your text, R is going to use escape sequences to denote those. So in this example, I start a string and end it with single quotes, but there are some double quotes inside. If I print that out, R will use the escape sequence to let me know that those double quotes don't denote the end of the string, but actually some text inside of it. If I'd like to print it as the text it actually represents, I can use the writeLines function. And there it prints out the text as it is literally meant to be, with no starting and ending quotation marks, and the quotation marks that are actually included in the text without backslashes. There are many escape sequences in R to represent special characters. In this first example, I use the backslashes to represent both single and double quotes. Printing out that code, you can see how they are represented in the final text using the writeLines command. There are other characters as well. For example, backslash t represents the tab character, and backslash n represents a new line. In my next example, I include a few of those. You'll notice in my output, there's a tab between the first two set of arrows and a new line between the second set of arrows. when I print it out using write lines. But again, just using the print function shows the escape characters that led to that string. The difficulty here is if you'd like to include a backslash in your code, the way you do that is you use the escape sequence of 2 backslashes to represent a single backslash. It's the example that I have here in my code. You'll notice in the first example, where I include just a backslash by itself, it's followed by the less than sign. That's not a valid escape character in R, and it generates an error message. In the second example, I use 2 backslashes to represent a single backslash that is read properly, and looking at the write lines function, it prints out a single backslash. Using all these backslashes can be very cumbersome. Starting with R version 4.0, there's support for raw strings. R interprets everything in a raw string literally, just as you type it. A backslash is interpreted as a backslash, not the start of an escape sequence. Double and single quotes are interpreted as text, not the start or the end of text data. So how do you denote a raw string? They start with a lowercase r, followed by either a single or a double quote, and then a left parenthesis, a square bracket, or a curly bracket. You can use any of those 3. You then end the raw string with a matching right parenthesis, square bracket, or curly bracket, and a matching single or double quote. I have some examples of valid and invalid raw strings here. On the left-hand side, every raw string is valid. The first one uses a single quote and a squiggle bracket to denote the start of the raw string, and the corresponding squiggle bracket and single quote at the end to denote the end of the raw string. The next example uses double quotes in the squiggle bracket. The third example uses double quotes and a square bracket. And the fourth example uses double quotes and a parenthesis. The important thing is, whatever you start the raw string with, you need to use the corresponding characters to end it as well. The examples that I have on the right are invalid raw strings. The first one forgets the R character that goes before a valid raw string. The second one doesn't include a squiggle bracket, a square bracket, or a parenthesis. You need to include one of these 3 to create a raw string. The third example starts with a double quote and a square bracket, but ends with a square bracket and a single quote. The quotation mark type has to match at the start and the end. The last example starts with a double quote and a square bracket, and ends with a squiggle bracket and a double quote. Again, the brackets types need to match for a valid raw string. So again, you can see where each one of these has gone wrong, and I've highlighted the portions that need to be adjusted to make valid raw strings. I have a few examples of raw strings here in R. In this first example, I use a squiggle bracket and double quotes. You can see when R prints it out, it interprets the backslash inside of that text as a literal backslash, and so it uses the escape sequence of 2 backslashes to print it out. Remember that you can use square brackets or parentheses, single quotes or double quotes, as long as they match. Here I use a single quote and square brackets. Here I use a double quote and parentheses. The important thing is they match. If they don't, R will give you an error message, or worse still, not realize that it's the end of your expression and think that there's more text for you to type. I use the escape key to exit from that error condition. Remember that when you use the print command, R will print out the literal string that you need to type to represent that piece of text. In this case, I've printed out a raw string. R still prints it out with the double quote format. If I'd like to see the text that it represents, I can use the write lines function. Notice that unlike previous examples, I get a \t and a \n here because R interprets the text inside a raw string as literal text and doesn't try and convert escape sequences into the characters they represent. Strings can also have NA values. Remember, NA implies no or missing data. Just like with numeric functions, NA strings pass through string functions and lead to NA values as the result. There's also an empty string. An empty string implies the data exist but are empty. So for example, Aristotle's last name is just the pair of double quotes, which represents the empty string. It has a length of 0, but it's still treated as a valid string by R functions and won't result in NA values unless there's some other reason that an NA value should be created. Let's just look at a few of these values in R. So you can create an NA value as text by using the as character function on the NA value. This is different from the empty string, which is just represented by double quotes. Notice that double quotes give me an empty string, whereas as character of NA gives me an NA value. Additionally, if I were to check to see if the empty string is a missing value using the isNA function, I get a false. But if I check to see if it's missing on the as character of the NA value, I get a true. Remember, this is because the empty string are data you're certain about. There's just no text data, whereas the NA string represents your uncertainty and is a missing value. Remember that numeric and text data are handled differently in R. A print function is always going to show text data in double quotes, but even if your text data are all numbers, the text data are still not numbers. R can convert text data into numeric data. It's not going to perform mathematical functions on strings automatically, but you can convert text into numbers using the built-in as dot functions and their corresponding as underscore functions. For example, as underscore integer would return the text argument as an integer, as underscore double would return the argument as a double, as underscore character is used for converting numbers into character data. Remember that if R isn't sure how to perform the conversion, it's going to return an NA. So if there's additional text beyond your number, R might not know how to convert it, and you'll get a missing value instead. The tidyverse also provides parse underscore functions, which are more robust. In particular, the parse underscore functions are locale aware, which means they'll accommodate the fact that different places have different conventions for writing numbers. In particular, commas and periods can mean different things. In the United States, the comma is the thousands separator, and the period is the decimal separator. That convention is different in other countries. When you use the parse functions, unless you tell R something otherwise, it assumes the current locale that's set by the language on your computer. You can override the locale with the locale option to the parse functions. As a few short examples, the asNumeric function will convert text into a number. R will determine the best format of number based on the information that's inside. Here I can run it on the text 1000, and it gives me the number 1000 in response. These functions only interpret literal text as numbers. So for example, the piece of text 1000 in quotation marks is unparsable by these functions, and R would return an NA instead.